everyone, thank you so much for clicking onto the video. Today we're going to be looking at elimination, so here are our learning objectives. The first is to know that alkenes can be formed from alcohols by acid-catalyzed elimination reactions, and then also that alkenes produced by this method can be used to produce addition polymers without using monomers derived from crude oil. And so by the end we should be able to outline the mechanism for the elimination of water from alcohols. We're then going to look at a required practical, which is the distillation of a product from a reaction. Now we're going to talk about elimination of alcohols. So an elimination reaction is where a small molecule leaves another molecule. And so in the case of alcohols, the molecule which leaves is the water. And so because we're getting rid of water, these elimination reactions are also known as dehydration reactions. Alcohols can be dehydrated by refluxing. Again, that's where the condenser is placed directly on top of a pear-shaped flask. And so when we vaporize and then condense, all the condensed mixture drips back into the mixture. And so it's refluxed with hot concentrated sulfuric acid or phosphoric acid, and these are dehydrating agents, all by passing the hot vapor over heated aluminium oxide, which is a catalyst. And by dehydrating alcohols, we can form alkenes. And these alkenes are used to produce addition polymers. And we can do this without using monomers, which are derived from crude oil. So this is a better way of producing the alkenes for making addition polymers. So we're going to look at the mechanism for the dehydration of ethanol to produce ethene. So we start off with some ethanol. And then we draw in the two lone pairs of electrons on the oxygen, because it's only bonded twice and there's two lone pairs left. And then we add the dehydrating agent, which is either the hot concentrated sulfuric acid or phosphoric acid. And this is represented by a H plus because they're both acids. And then what happens is that a lone pair of electrons on the oxygen are attracted to this H plus because they're negatively charged and the H plus is positively charged. And so they move towards this H plus ion. And then what we form is this sort of intermediate where we have CH3, CH2, and then the oxygen, which has now formed a bond with this H plus, and it already had that bond with the hydrogen. And so now the oxygen is actually positively charged because we've gained a H plus. And now what happens is that the electrons of this covalent bond move towards the electrons on this covalent bond. And then what happens is that the electrons from this covalent bond then move towards the oxygen to remove that water. And so what we form is we form ethene, so the double bond is formed here when we do this step. And then we have a leaving group, which is here. This group is leaving, and so we form a water. And we also form a H plus ion, which comes from here. This hydrogen has become a H plus ion because it's lost the electrons that it was sharing with the carbon in that covalent bond. And so this is an elimination reaction. Because we're eliminating the water from this alcohol. So now we're going to have a look at the dehydration of hexanthriol. Now, like when we were doing elimination reactions, we can actually form more than one product sometimes when we dehydrate things. So if we dehydrate this with aluminium oxide, acting as the catalyst, and also at a temperature of 600 Kelvin, we can actually form two different products. And this depends on which water we take away. So we can either take away this water or we can take away this water. And this forms two different products.